This is the circuit diagram of center tapped full wave rectifier, and this circuit is also called a biphase full wave rectifier circuit. Let us understand the working of center tapped full wave rectifier. During positive half cycle, terminal A is positive with respect to C and terminal B is negative with respect to C. So therefore, diode D1 is forward biased and D2 is reverse biased. Hence, diode D1 conducts and D2 does not conduct. So there is a flow of current from terminal A through D1 via RL towards C. So the flow of current through RL develops the positive voltage across the load resistor RL. During positive half cycle, terminal A positive and terminal C is negative, which makes the diode D1 forward bias. That means it acts as a closed switch. There is a flow of current through RL which develops the voltage across RL during positive half cycle. During negative half cycle, terminal B is positive with respect to C and terminal A is negative with respect to C. Therefore, during negative half cycle, the diode D2 is forward biased and D1 is reverse biased. So D2 conducts and D1 does not conduct. Hence, there is a flow of current from terminal B through D2 via RL towards C, which develops voltage across RL. So if you observe, during positive half cycle and negative half cycle, the current direction is same through RL, which develops the voltage across RL, which is pulsating and unidirectional. Positive half cycle, terminal A is positive with respect to C and terminal B is negative with respect to C, which makes diode D1 forward biased and D2 reverse biased. The diode D1 conducts and D2 does not conduct. During negative half cycle, B is positive with respect to C and terminal A is negative with respect to C. So which makes D2 forward biased and D1 reverse biased. Hence, diode D2 conducts and D1 does not conduct. So during negative half cycle, there is a flow of current through resistor RL due to conduction of diode D2. Here, the input signal and output signal are shown in the figure. During positive half cycle, the diode D1 conducts and D2 does not conduct. So there is an output voltage due to the conduction of diode D1 during positive half cycle. So this is our input voltage. Positive half cycle, which produces the output voltage positive half cycle across RL. During negative half cycle, there is a output voltage due to conduction of diode D2, negative half cycle. If you observe the waveform, the direction of current is unidirectional, which will produce a pulsating output voltage, pulsating DC. Again the cycle repeats, the positive half cycle comes, diode D1 conducts, which will produce the voltage across RL. Again the negative half cycle, which will produce the output voltage due to the conduction of diode D2. The voltage VDC, that is average output voltage, DC voltage, is represented in the waveform, which is equal to 0.636 Vm. The DC voltage is mentioned in the output waveform, which is equal to 0.636 0.636 Vm. The expression for output voltage is VDC equal to 2 Vm by pi, which is equal to 0.636 Vm. Thank you.